Alright guys, so in this video here, we're going to go over several example. I'm going to focus on example 1 and 3 here. Just kind of go through and determine the null and the alternative hypothesis and how to formulate using symbolic form and just write out in words so that way it makes sense. So let's start with example 1 here. This saying that leading news authority claims that the president's job approval rating has dropped over the past 3 months. So we're given that the president job approval rating has been dropped. Previous polls put the president approval rating at minimum rate of 56%. So the president chief of staff is concerned about this news report since it is an election year. He wants to run a test on the claim. So the previous poll shows that the president approval rating is at 56%. Okay. Now there is a recent source, some leading news say that the president jobs approval rating has dropped over the past 3 months. Okay, so this again, this could be fake news or real news. We don't know. So the chief of staff is going to do a test. He's going to collect some sample data. He's going to do a poll. He's going to do a survey, see if that the rumor is indeed true or not. Okay, so this deal with proportion. Rating approval, that's the percentage of people approve or not approve. So this deal with population parameter of proportion. Okay, so here's the claim. Okay, so first we write this claim in symbolic form. So we say that the claim say that the proportion, the president jobs approval rating is what has dropped over the past 3 months. I mean, it's less than 56%. So to describe this, we say that the president job approval rating percentage is less than 56%. That's what that statement means. Okay. So now the null hypothesis. Before we collect the data, we're gonna say suppose that p is equal to 0.56. Okay. So this means that the president job approval rating is equal to 0.56. So by definition, when we write our null hypothesis, it always has an equal sign in the statement. Okay. So now the alternative. So keep in mind that if this claim was false, right, then the data we need to be able to show that will have p being greater than or equal to 0.56. Okay. To work with the single distribution, we're going to use the equal part, because when something is greater than or equal to, you just have to show one of those things is true. So we're going to go with the equal part. Why? Because this allows us to look at the distribution of p hat, and we have this result here. We'll get into the detail of that soon when we actually do an example. So we got the null hypothesis, p is equal to 0.56. The alternative, again, so alternative is as h sub 1 or h sub a. P is going to be, okay, so it's going to be the opposite of the null hypothesis statement. So the null hypothesis statement in this case is stand for greater than or equal to 0.56. So the opposite of that is going to be less than 0.56. So in this case here, it is the same as the claim. So at the end of the problem or the hypothesis testing procedure, we either support the claim based on the evidence, or we don't support the claim at all. Okay, so these two hypotheses here, the null and the alternative, it turned out the way different author look at this differently. I mean, there's a whole more than just one way to go about it. But in our book, the way we go about doing it is one of these statements, one of these hypotheses is the claim. Okay, that's how we're gonna set this up. Is one of those statements has to be the claim itself. Okay, so that way at the end of the process, we either support the null and reject the alternative, or we support the alternative and reject the null. Okay. All right. All right, we are going to skip example 2 here. I'm going to go into example 3. So this deal with population mean. So this saying that a nationwide study shows that children watch an average or a mean of 3 hours of television per day. A mother in Louisiana believes that this is an underestimate for children in her area. She then conducts a local survey to test her belief. So, there's a nationwide study showing that on average, children watch around 3 hours of television per day. But again, this is nationwide. But what she's saying now, she's going to apply that result to her, local, her neighborhood. She probably gonna survey, 10, 15 children in her area and to see if, it's going to be close to 3 hours or more. And when she said that she believed this is an underestimate for her children area, she are making a claim. She are claiming that, or she wants to show that the average of hours television watch per day of a children is much greater than 3 hours. Okay, so that's what she wants. But let's go back to the problem here. So it depends how you really look at this here. If you just look at this from a neutral perspective, we start with the statement. This right there will be the claim because it's based on nationwide study. That just some study showing that. So the claim is mu equal to 3 hours. Okay, so this saying that the mean hour of TV watch per day by children is 3 hours. Okay, that's what that statement's saying. Okay, so now the null hypothesis. Okay, so by definition, the null hypothesis is always equal to the claim value. If the claim value is 3 hours, we're going to start with, so suppose that is equal to 3 hours. Okay, so this is the same as the claim, so the claim itself. Okay, so sometimes the null hypothesis is the claim, sometimes the alternative is the claim itself, so it depends. Okay. Now, if the data come back, if the survey come back and said, you know what, we survey 20 children and we found that the sample mean is 6 hours per day for children in a local neighborhood. So that's way above 3 there. So it's gonna be what we're gonna go by if we don't support this. What would be the alternative that we're gonna go by? So in this case here, we can go by this here. We can go by that the mean is not equal to 3. So that will provide the two-tailed test later on when we discuss more detail. But in this case here, we're going to go by what the mother in Louisiana believes. So she believes that this is underestimate. So she wants to reach her conclusion or her claim that the mean is much greater than 3. Okay, so this is what, this is saying that the average hour watched by children is greater than 3. Okay. All right. So hopefully that makes a little more clear how do we determine the null and the alternative. It's gonna be slightly different when you do the homework on my math lab. Is the format certainly won't be the same, but just go by definition. The null is always equal. The alternative is gonna be the opposite with the null. Okay.